And today I'm here with Matt Kohosek and my team. We will be talking about unlocking membrane return on investment, as you all know. So we'll be talking more about what are the proven strategies for extending the membrane life and for having a stable performance, and also what are some smarter bid decisions that will help the decision makers do the bid evaluation process in a better way. Before that, let me just give a quick introduction about who we are. We are Aria Filtra, a division of Trojan Technologies, and we are the filtration partner of choice for our municipal and industrial customers. We were formerly called as Paul Water. We are now called as Aria Filtra. We have more than 30 years of experience with over 700 installations worldwide. We provide reliable solutions to our customers, tackle some uh, complex water treatment challenges, and that's we provide high quality water to our customers. So to know more about our products and services, you can visit our website, or you can reach out to any of us attending this presenting from our team in the seminar. So I'll quickly introduce myself and Matt here. We both come from the applications engineering team with Aria Filtra. I bring experience in the system, like water treatment, membrane-based water treatment system, and I support the projects through from early concept through proposal development. I also have prior experience in water disinfection technologies. And with me, we have Matt Kohosek here. He's our senior manager of the filtration department at Aria Filtra. And he has been in the industry for over 10 years with various different roles with different organizations. So with that, I move on to our agenda for today. So we are going to talk about what are the drivers for total cost of ownership, how we can optimize the total cost of ownership. And we are going to pair that with some case studies from explaining our long running MF installations. And we are also going to talk about the difference between premium and budget modules. We also have a Q&A session in the end. So we'll get to you. You can paste your questions and we'll get back to you at the end of the webinar. And we also have a quick survey at the end of the presentation. So if you can just give us feedback, we would appreciate it. So with that, I'll hand over to Matt and he'll explain the TCO concept and drivers.
Hi, everyone. Looking forward to talking with you here today. So you bought your new membrane plant. Now you have to make sure that you get the most out of it. So how do you do so? So we're going to talk a little bit about some of those drivers for what your total cost of ownership is as you operate that plant. Now, this is a little disclaimer. This is going to be focused around pressurized polymeric membrane facilities, MF and UF. There's lots of other technologies out there. So some of the numbers you're going to see and some of the references you're going to hear about are all based around that specific technology. So we have a poll. We have our first poll. And so the poll should pop up for you on the right. What is the largest life cycle cost you deal with in a membrane plant? Let's hear your feedback on this. Is it energy usage? Do you see that as the biggest life cycle cost? Is it replacing your membranes? Do you see as chemical usage? Or is it maintenance, your general maintenance costs, your fiber pinning, or some others? We'll give you a moment to respond to that poll there. It's looking like we have a bit of a split here with the audience. That's great. We can keep that up for a minute, let you guys keep responding. But it looks like initially energy usage and membrane replacement are the top two life cycle costs that most people are seeing. That's great. So kind of show you a little bit of some analysis that we've done here. So when you look at a membrane facility, you can look at it over a certain time span. We chose to look at it for this presentation on a 20-year period. And the reason we chose a 20-year period is that's what a lot of bid evaluations are done on. So when you're looking at, you get a new facility, maybe you do a net present value calculation for the life cycle costs. Usually it's done on a 20-year period. So that's what we did. Now, sometimes we've seen it as 25-year period, 30-year period, even sometimes it's done as low as a 10-year period based on the specific application, specific customer request. We did this here on a 20-year period. So as you can kind of see here, your biggest cost is capital. I think most people know that. It's a big investment in a membrane facility. So you want to make a good decision because you do have to live with that decision for at least 20 plus years usually there. So one of the things to note though is over that 20-year period, you're going to pay about equal to even more in your operating costs or your life cycle costs in your membrane facility. So it's interesting when we look at the poll, a lot of people said energy usage was the top cost that they see. And then the second, membrane replacement. Those are the two biggest life cycle costs that we see. And we show these operating costs. We put module replacements, energy, and chemicals in here. And really, these are the easily measured ones. We see them in bid evaluation. You see them up front. Now, there's a lot of hidden costs in operating a plant. Maybe it's fiber pinning, other maintenance, operations, paying your staff, things like that. You don't see a lot of those in the bid evaluations. But the bid evaluations are set up to quantify upfront, the factors that are going to inform your decisions for how long your facility is going to operate and what your total cost of ownership is going to be. So as you look through here, the biggest life cycle cost that we've seen is the module replacement cost. And this is based on having two module replacements over a 20-year period, as we mentioned, and that's most bid evaluations are set up, and that's how it is done for polymeric membranes. And usually that is your biggest life cycle cost, followed by your energy usage, and then your chemical cost is usually fairly low. And then the chemical cost there is based off of a 7-day maintenance clean or EFM, enhanced flux maintenance. That's one of what we've coined our procedure, and a 30-day clean in place process. So if you change that operating protocol, change those cleanings, that's going to adjust your chemical usage numbers. But in the end, it's usually your lowest of the big three operating costs. And as you can see, the larger your facility gets, the more critical your operating and replacement costs can be. As we get bigger, your more modules to replace, more energy usage. So it's going to be a much more critical decision when you have a larger facility on your operating costs. But the largest one that we've seen is your module replacement cost. So kind of dig into that a little bit more and look at your module selection, the impact of your module selection. So this is going to kind of further illustrate the impact of the modules and how important it is. Now, the number of module changeouts can vary that you have in a facility based on your application, your module quality, your water quality, your pre-treatment, and we're going to get into some examples later on so that you can kind of see some of the best practices there. But we put a number of 2 module replacements up front. Sometimes you have 1 if they can last extra long, or sometimes you have 3 plus. But that difference between 1 and 3 module replacements can be huge from a financial standpoint. It can be $1 million to $1.5 million difference in just a smaller 5 MGD facility, and then in a large 20 MGD facility, you're talking $4 to $6 million over that 20-year period that you would end up having to pay. So we see some of the drivers for the module change out, right? When fibers break, right, you'll start to the modules will start to struggle to perform, can't recover permeability anymore, and other performance challenges that might occur you want to make sure you're changing them out. But the critical thing is to select a premium module with an optimized operating protocol. You're going to hear us mention that quite a bit here, is a premium module with an optimized operating protocol, because that will have significant long-term implications and is going to really drive your total cost of ownership. So when you're purchasing your new facility, usually you've gone to bid of some kind. You have an engineer, they develop a specification, and there's usually some type of evaluation criteria that is part of that decision that you're going to make. And the bid stage, this is your opportunity to pick the best system and module. And the bid criteria that you set up, it's usually based on the requests that you may have as an owner, or it's based on the recommendations of the engineers and their experience. And there's a lot of engineers out there that have a lot of very, very good experience and can help guide owners. And the engineers really do their best to get the best selection for their owners, and they will help guide you through the process. A lot of times we see from a technical criteria standpoint, it's usually on the lower end of things where you're looking at, the footprint you're going to take up, the experience of the manufacturer that is providing the membrane facility. And then also you've got financial criteria, which usually outweighs the technical criteria. And your financial criteria is usually split into your capital cost and then your 20-year operating costs, which is usually broken down into an NPV or a net present value calculation, combining the energy, chemicals, and module replacement, and sometimes waste disposal as well. There's other things that may come into play there. And that 20-year NPV, it's meant to mimic the actual total cost of ownership that you're going to experience over the life of the product. But one of the things that we've noted is it's not always reflective of what you're going to actually pay over that 20-year period. We'll have some examples, as we mentioned. Manasi is going to walk us through some examples of some sites that have been able to really optimize the total cost of ownership, and it really wasn't reflective of what they thought they were going to pay on day one. So there's some flaws in the traditional bid evaluation criteria that we see today that can prevent you from making sure you can get the biggest cost of or the best cost of ownership in your membrane facility. So before I hand it back over to Manasi and start walking through those, the key takeaways from this section, the setup here, is the main drivers for your total cost of ownership really is module replacement, and also energy as part of it. Module replacement is your largest life cycle cost usually in operating a membrane plant. So selecting a premium module, that's really critical, as the basis of putting a premium module into your installation with an optimized operating protocol can have a significant long-term impact. And a lot of the ways that we evaluate things today may have some gaps in making sure that you get that premium product up front. So I'm going to turn this over to Manasi here, and she's going to talk through some case studies of facilities who have optimized their total cost of ownership.
Awesome. Thanks, Matt. So before that, I'm curious to know, how frequently do you change your membranes? Is it less than 5 years, 5 to 7 years, 8 to 10 years, or more than 10 years? I'll just wait for some time. Wow, that's nice. So the major response is on the more than 10 years. There's a tie between second and third options. Okay, so you can keep on giving responses, but overall, I think more than 10 years and 8 to 10 years is what I'm seeing. It's the major response. So yeah, thanks for your responses. And then I'll move to our next slide, which is levers to extend membrane plant life. So consider your water treatment system as your home. So always the foundation it should be strong. It's everything that holds together in place. So your premium modules in this case are really the foundation. As Matt mentioned, the module selection should be the can't emphasize more on the module selection part, because you or the decision makers, they select the modules and it happens, it's a one time thing during the bid evaluation, like the whole process, and it should be done right. So Matt will also explain more about premium versus budget modules, but this is the first step. The second step can be the efficient pre-treatment, which is nothing but the strong walls of the house. And sometimes, like, all these, apart from premium modules, anything else can be adjusted or improvised. So depending upon the water quality, the pre-treatment can be evaluated, but it's essential to have it if the water quality is challenging. The next one is proactive maintenance. It's as good as the regular upkeep and servicing of the house. And what comes under that is the module autopsies, regular maintenance, service visits, monitoring of the performance, etc. And last but not the least, and the important one, is the efficient cleaning strategy. So this is nothing but the deep cleaning of the house. And I'm going to explain a little bit later, like how this helps to extend the life of the membranes. But the table on the left really shows like what would happen if any of these levers are skipped or not paid attention to. Like, for example, premium module. If the module is not selected properly, there can be early fiber damage, because integrity of the modules is really important in having a long life of the plant. If efficient pre-treatment is not done, and it's required and it's not done, so what would happen is rapid fouling of the membranes, which further needs more CIPs to be done, which means more chemical exposure, which means short life. So we don't want that. That's why pre-treatment is super important. That is followed by proactive maintenance. So this is a really like, this lever has a lot of weightage really, because what would happen if it's not there? There would be undetected performance. Somewhere in the background, the performances would degrade and equipment would be failing and you would not know. And suddenly, something happens and you start seeing the decline in the performance. So I think proactively monitoring your system is it's super essential. And the last is effective cleaning. So if that is not done, then the membranes would foul, and that would be an irreversible fouling, which would in turn shorten the life of the membranes. So with this background, let's move on to some case studies. So I'm going to talk about 3 case studies which represent our long-running MF installations. And these plants, so there are small plants, the capacities vary from the small plants to large plants, and even the water varies too. So let's talk about the Queens Junction water treatment plant, our first case study, which is located in Utah. So this plant is a medium capacity plant, 5 MGD, designed for 38 GFT, currently operated at 15 GFT. So this plant utilizes the Mycorrhiza hollow fiber membranes. The plant has been running since 14 years now in continuous operation. There are 5 racks with 88 modules each, and the water is the source of water is surface water. It's moderate to high. It has moderate to high turbidity, TOC, hardness. So this has a therefore it has a pre-treatment of direct coagulation upstream of the MF. And then there's also a plate settler, which basically consolidates the waste coming from the backwashes of the MF and the strainers. And the decant from the plate settler is recycled back to the upstream of the MF. And that approximately is 10% of the total water coming into the MF. So here's the performance of the plant. This is from last year. One insight we have is the city decided to do a health check of these membranes, and this was done after 10 years of stable performance. So as a part of proactive maintenance, an autopsy was performed, and it was revealed that the membranes have inorganic fouling. So our process engineers, they introduced high strength CIPs within the operating protocol. And since then, like, it's been working really well. We are able to maintain the specific flux in the required window, and the cleaning protocol, the regular chlorine EFMs, monthly CIPs, and then the annual high strength CIP, which then became a regular practice, has really proved, really has contributed towards the long life of the membranes. And one thing I would like to mention is this plant, we really have our process engineers proactively monitor this site and make sure that the performance is up to the mark. Some challenges that the plant faced and what improvements were made. I'd like to talk a little bit about this. The city has done a really great job in identifying these challenges. And as a part of pre-treatment, they implemented chlorination step to oxidize manganese, which which helped the the MF system further. They also implemented pH depression to control the scaling, because the raw water, as you saw before, has moderate to high hardness. And they also introduced a settling pond to reduce the turbidity further entering the MF. And apart from this, they upgraded their water softener. They did dose optimization for ACH. A little background on this, so there was a module autopsy done where inorganic fouling was detected. So following to that, the city did this ACH dose optimization, and then they capped the dose to 10 ppm to avoid any carryover to the MF. And the annual cleaning of the raw water pipe is also done as a part of the maintenance. So some key takeaways from this case study is that how proactive maintenance and pretreatment upgrades have helped extend the life of the membranes. The module autopsy has helped diagnose the inorganic fouling issue in time. And the regular cleaning or even the high strength CIP has made sure the performance is up to the mark. One highlight I would like to make is the fiber durability. So this plant, the modules have excellent integrity, as we have seen only 8 pinnings in 10 years, which is excellent. And then the specific flux, the average specific flux has always been 8 GFD per PSI, so which means sustained performance. So with that, I conclude the first case study, and I'll move on to the second one, which is Town of Basalt water treatment plant in Colorado. It's a comparatively small plant, just 0.5 mgd, and designed and operated at 46 GFT. The plant utilizes the microza hollow fiber membranes, and the best part about this is the plant was running for 22 years in continuous operation, and the modules were replaced in 2024, but the decision was budget driven totally and not performance driven. And the customer was really happy with the performance of the membranes, especially because there were only two pin fibers in 22 years, which is outstanding. So the source for this plant is spring water under the influence of groundwater. The water is pretty clean, so there was no need to do any pre-treatment prior to the MF. Let's see the performance. So this is a graph showing the permeability for over 20 years of operation. And as you can see, we have stable, consistent, long-term performance. And what really has contributed is the regular chlorinated backwashes and annual CIPs and consistency in these cleaning strategies. So some key takeaways from case study number 2 is exceptional longevity. So what has contributed really to the longevity is the proactive approach and the simple operation, consistency in the simple operation and cleaning strategy. So even though it's simple, it was done consistently, the chlorinated backwashes and annual CIPs. And effective cleaning strategy has also proven in restoring the permeability. So with that, I conclude the second one and move on to the third one, which is Missouri City Water Treatment Plant in Texas. Now, this is a large plant. It's 20 MGD. With the current demand is up to 15 MGD, and it's operating up to 57 GFT. The membranes are again the microza hollow fiber membranes. And in this case study, I'm going to focus on the first 5 racks because this plant has 10 racks with total 700 modules. But the first 5 are 10 to 14 years of age, and the last 5 are comparatively new. And they are a part of the rack expansion. So the source of water for this plant is the Brazos River, and it has moderate to high TOC hardness iron. So the pre-treatment was very much essential for this kind of water. And what consists in pre-treatment is the settling pond, coagulation, and sedimentation. So obviously the water which goes to the MF has less turbidity, which is 0.5 to 0.7 NTU. The replacement for the first 5 racks happened in a staggered fashion, and that was done after 10 to 14 years during the rack expansion time, which was also a budget-driven decision. So what really contributed to such a long life of these membranes is really, again, the proactive maintenance strategy. So Paul Water, which was then called Paul Water, now we are Aria Filtra, we had a service contract with City of Missouri. And as per that contract, we did module autopsies, regular module autopsies, and we also had semi-annual service visits by our field service engineers. So I'm going to quickly show you the results of the module autopsies. So as you can see, in the first 5 years, the module autopsies revealed that the permeability declined over the years up to 75%, and then it was forecasted that it would further decline. However, during the rack's expansion time, it was about the same time, our field service engineers and process engineers, they proactively monitored the site and they did some adjustments, and some of them were dual side cleans, high strength CIPs, and because of that we could get deeper recoveries. We also did some FM volume adjustments. So, and the outcome was that we were able to restore the permeability back to the baseline. So with that, my key takeaways from the case study number 3 are that proactive maintenance. I can't stress further, but this has really proven very effective in extending the membrane life for this plant. And that's nothing but the routine checks, CIPs, autopsies. And in spite of the challenging conditions of the raw water, the effective pre-treatment has also helped extending the life of the membranes. So with that, I would like to summarize all 3 case studies. I'm not going to read each and every point here, but one would just like to emphasize one common theme here is that proactive maintenance, if that's paired with cleanings, informed cleanings, then that can result into major cost savings. And that's what we have shown here. So for Queens Junction, we were able to save 250K over the lifetime of the plant. For Town of Basalt, we were able to save 60K, and for Missouri City, it was over 200K worth in savings. So with that, I hand over to Matt, and he's going to explain the difference between the premium and budget modules.
Thanks, Manasi. You guys can see there's been some examples of sites that have really extended their life. And it's great to see in the poll as well how many of you have been able to have your modules last longer than 10 years, which is fantastic. Still looks like about 47% of the responses mentioned that they're not making it to the 10-year mark, which is what we see most membrane warranties based on. And there's definitely always different reasons for that. But we're going to get into a little bit about some tips for how to get a product and a partner that's going to help you optimize your total cost of ownership. And we're going to talk a little bit about and expand upon our understanding of what makes a premium module and some best practices for bids for getting a premium module that can last over time. So we have one more poll here. What carries the most weight in your water or wastewater RFP evaluation? So when you do a bid, you send out a bid, what do you usually have as the highest weighted items? What's the most important to you? The total life cycle cost, capital plus operating cost, the actual technical performance and reliability of the product and partner you're going with, if they're complying with your specifications. You know, that's very important. A lot of work goes into developing those specifications. And then, or is it the experience and support that that vendor has either provided in the past or the amount of installations that they have? So as these some answers are popping up here. I like seeing a lot of the technical performance and reliability higher weighted. That's great to see. That's important to a lot of people. It looks like we've got a good split here between the life cycle costs and the technical performance and reliability. And that's great. That really plays into a little bit about what we're going to be talking to here. So you've heard us use this term premium versus budget modules, and we're really focused on PVDF modules, as I mentioned before. To look at your total cost of ownership, and you really want to make sure you go with the premium modules we've mentioned. So what's really different? This is where we kind of break it down into what we call the 3 R's: resiliency, reliability, and robustness. So when we say resiliency, can the performance be recovered with chemical cleaning? Manasi showed some examples of sites that did a great job with their chemical cleaning, doing some high strength CIPs to restore the modules back to their original permeability in many cases. Reliability, consistent performance over time. We saw that from one of our examples as well, specific flux being maintained for an extremely long period of time. And then robustness, fiber breaks. We saw that in a lot of the examples too, is the low fiber breaks a lot of these sites had. And at the heart of all of that is, a premium product, a premium module. So how do we actually quantify or give you the description of the premium module, right? We say resiliency, reliability, and robustness, but what does that really mean? Well, from a dollars and cents standpoint, right, we broke the cost down into, square footage, because we know many modules out there, different square footage, different surface areas. So you can kind of see the premium module will be a little bit more that you pay for versus a budget module. But the key thing, when we talk about robustness, replacement frequency. How often are you going to have to replace where these 3 R's are not maintained? And premium modules are going to last 10 to 15 plus years. We see a lot of you have premium modules in your sites, which is fantastic to see. The next point is permeability recovery. The module should be able to recover to over 80% of its baseline in many cases. That's what a premium module will be able to do. And then fiber breakage. We saw the low fiber breakage in a lot of the examples. We're going to talk a little bit more about fiber breakage in upcoming slides. But a budget module is going to see high fiber breakage, where a premium module, you're going to see less than 0.1% and really less than 0.05 and even lower than that is what you really should be seeing. We're going to quantify that a little more later in the presentation. When we talk about fiber breakage, I think a budget module, a good way to summarize a budget module is it ships with pins with the module due to potential out-of-the-box failures. And that's a good way to judge a budget versus a premium module. Now, looking at the chart in the top right corner there, the 20-year membrane replacement costs. If we look at this, a budget module for this is half the cost, and here in this evaluation, but you have 2 to 3 times the changeouts with a budget module versus a premium. And when you look at the charts here, the red bar versus the blue bar is really what you end up paying for that additional replacements of a budget module versus a premium module. And when you look at the red bar versus the black dot there, that's the difference between what you actually paid and what you expected to pay on your bid evaluation. So that's the additional cost. Where on the blue bar with the premium module, the difference between the star and the bar is what you actually saved from what you expected to pay at bid time. So it can have a big swing. You can make your membranes last long, like they have in the case studies that Manasi shared here. And not to mention, with all of this, there's the environmental benefits of reduced replacements with a premium module versus a budgetary module as well. So we're just going to share, this is our module, the UNA, and we have 2 versions of it, the UNA 620A and UNA 620A DCA. So the UNA 620A has been in the market for 20 plus years. We've seen a lot of great performance with it over that time period. And then the DCA is the new evolution of it. It's a larger surface area. It's got about double the surface area of the original UNA. So we did a study because with UNA had been out there so long, we found some sites that had modules that had been installed for more than 12 years here. So we did a study of 35 sites here. And of those 35 sites, only 2 of those sites had greater than 10 broken fibers. And so just to kind of put that into perspective, there's over 6,000 fibers in a single UNA module. And these are sites with dozens, hundreds of modules. So, 200,000 to 2 million fibers are at these sites. All right. And for these sites that had 12 plus years of running, only 2 of those sites had more than 10 broken fibers themselves. So that's 10 broken fibers versus 200,000 to 2 million at each of these sites. And the majority of them had less than 10 broken fibers, which is really showing the durability of this product. And when we talk about the robustness, the 3 R's, the third R is robustness. And we think the UNA is the model for a robust module. So if you want to get a premium module into your bid, what are some of the best practices that we would recommend? I see a lot of people on here talking about the technical performance and reliability being so important to them. What are some of the ways that you can do that? Well, some of the best practices that we've got here these are the kind of general requirements, the right to play. And the first thing is the warranty. Warranty should be a huge focus because a warranty is what a manufacturer uses to stand behind their product. And so you want to make sure it's at least a 10-year warranty. We've seen warranties less than 10 years on bids, and these modules can last at least 10 years. No one should really be offering anything less than a 10-year warranty. And even better than that is focusing on the absolute period. We recommend it. We offer a 5-year absolute, 5-year prorated warranty on our module. And we would stand behind that in many ways. Really push your manufacturer to offer a warranty like this, because that's really how they stand behind their product. And in addition, you want to have some references. Require at least, we recommend at least 10 reference sites on a similar water source to back that warranty. So this way you have that comfort, that proof, that it's going to last and it's going to work. The second point there is fiber breakage. You want to make sure you have a fiber breakage rate in your specification. We recommend, we really prefer less than, a 0.05% fiber breakage rate. And just to quantify that, that's 3 to 7 fibers per year is really what the max is that we think you should require from your manufacturers. And lifetime of a module, 0.5% is really the max as well. And this is depending on the number of fibers, obviously, is in the module itself. But make sure you're very stringent with these requirements for fiber breakage, because the module should be able to last, and a well-built, durable module should have very, very low fiber breakage rates. And then finally, with piloting or experience on the water source, really want to make sure you have that experience with both the module and the integrator that is doing it, because you're making a partnership here, and you want that partnership to last. And so you want some experience. So a pilot is a great way to get that experience and to learn. Or if you don't have a pilot, making sure that you have actual experience on that water source itself, so and you have that comfort that it's going to work. Now, this is the, as I mentioned, these are the just right to play. Now, when you're doing your actual evaluation criteria, how do you score it? Right? We talked before. Usually, it's 0 to 40% from a technical perspective in many cases, and 60 to 100% in life cycle costing or financial criteria. Want to make sure we're really stressing the technical and experience criteria here. And I think we're talking to a great audience for that, as I mentioned. The technical criteria is really how does the partner designing the facility to meet your needs? Right? What are they offering that may be harder to quantify from a dollars standpoint? And it really forces creativity with your vendors, and make sure that that they are aware of what's important to you as a customer. And there may be different things in your application, and you want to make sure that vendor is in tune with that. So that's where the technical criteria comes in. If the warranty is important to you, they're offering extended warranties. If you have an expansion plan, do they really curtail around that expansion plan and give you the best options for expanding in the future? And making sure that's really, really valuable. The second thing is experience. Think about this. If you're having surgery, would you want a doctor who's done hundreds of surgeries before, or one that's only done a few, maybe a dozen or so? Right? In this case, you're putting in a water treatment facility that's going to provide water for thousands of people. Would you want to partner with someone who has hundreds of installations, or someone that only has maybe a few dozen? That experience factor matters as we're treating water and we're delivering water for the public. And you want to make sure you have strong financial criteria as well, right? It's important, and we see from the poll, right? It's very important to a lot of people. And you need some dollars and cents, right? You want to be cognizant of how you're spending. Maybe if it's a municipal application, your tax dollars. If it's an industrial application, your company's funds. It's very, very important. You got to find the balance. You need to balance these out for what's most important to you with your specific application. And based on the size of the facility, as we mentioned, they can be different. and what's really important to you as a customer. And so that's our presentation here today. We have a few things in the Q&A section that we can talk to. But want to first off do some special acknowledgments. Quinns Junction Water Treatment Plant, Town of Basalt Water Treatment Plant, and Missouri City Water Treatment Plant. They've all been very, very good to work with through this process. We really appreciate all their feedback and partnering and all the work that they've done to make their plants successful. And they're all very, very invested in it. A reminder as well, when you exit, you're going to get a survey. Please fill out that survey, and we appreciate your feedback as well. If you want to know any more, scan that QR code there and or follow us on LinkedIn.